Good afternoon, students. Welcome to the mathematics class. In this class, you will learn about the chapter cubes and cube roots. Today, I will discuss about the definitions of a cube of a number and how to determine whether the given natural number is a perfect cube or not by using prime factorization method. So, let's begin with the definitions first. Cube of a number. Cube of a number means the number appears 3 times in a multiplication. So, the cube of a number is that number raised to the power 3. Thus, if x is a number, then the cube of x is written as x to the power 3. So, x to the power 3 is equal to x is multiplied by x multiplied by x. So, when a number is multiplied by itself 3 times, the product so obtained is called the cube of that number. For example, when a number 2 is cubed, we write it as 2 to the power 3. So 2 to the power 3 is equal to 2 is multiplied by 2 multiplied by 2. That equals to 8. So the cube of 2 is 8. Similarly, 3 cube means 3 is multiplied by 3 multiplied by 3 is equals to 27. So 27 is the cube of 3. Let's see another example, 4 cube. 4 cube means 4 multiplied by 4 multiplied by 4. That equals to 64. Now, if we take negative numbers, that means if we find the cube of negative numbers, then what will happen? For example, cube of minus 2, that means minus 2 to the power 3 is equal to minus 2 multiplied by minus 2 multiplied by minus 2. That is coming here minus 8. That means negative number we are getting. Also, cube of minus 3, that means minus 3 to the power 3 is equal to minus 3 multiplied by minus 3 multiplied by minus 3. That is coming here minus 27. So, from these examples, we can say that cube of a positive number is always positive and cube of a negative number is always negative. Also, the number 8, 27, 64 are cubes of natural number 2, 3 and 4 respectively. So, we say such numbers as cubic numbers or perfect cubes. Let's see the definitions of a perfect cube. A natural number is said to be a perfect cube if it is the cube of some natural number. In other words, we can say that a natural number x is a perfect cube if there exists another natural number y whose cube is x. That is, x is equals to y cube. So here x is a perfect cube because it is the cube of some another natural number, that is y. For example, 64 is a perfect cube because there exists a natural number 4 such that 64 can be expressed as 4 multiplied by 4 multiplied by 4, that is equal to 4 cube. So 64 is a perfect cube because it is the cube of another natural number, that is 4. But 16 is not a perfect cube because there is no natural number whose cube is 16. Now we will see how to determine whether the given natural number is a perfect cube or not. The following steps to be followed. The first step is we write the given natural number first. Then we express the given natural number as a product of prime factors. The third step, we group the factors in triples in such a way that all 3 factors in each triple are equal. If after grouping no factor is left over, then the number is a perfect cube, otherwise not. Now to find the natural number whose cube is the given number, we take one factor from each triple and multiply them. The cube of the number so obtained will be the given number. So let's see some example to understand the method. Let's see one example to understand the method. Is 216 a perfect cube? If so, find the number whose cube is 216. Here the given number is 216. So expressing 216 as a product of prime factors. So when we express the given number as a product of prime factors, that method is called the prime factorization method. Here already all possible prime factors of the given number is shown. As the given number is 216 whose unit digit is 6. So we start our calculations, divisions with 2, which is a prime number, and we know that even number is always divisible by 2. So here we start our divisions by 2. After that we are getting again an even number. So we again divide it by 2. So after that it is again 54, which is even number. So again we divide by 2. Here we are getting 27. So we divide it here by 3. Then we are getting 9. So divided by 3 we are getting 3. As in the last we are getting the prime number. So no further calculations is required. We can stop our calculations here. After that we express the given number, that is 216, as a product of its all possible prime factors. After expressing as a product of prime factors, we make a groups of the equal prime factors in triples. So here we can see that here we are getting two groups. In the first group 3 2s are there. In the second group we are getting 3 3s. So which can also be written as 2 cube multiplied by 3 cube. So after grouping the equal prime factors in triples, we find that no other prime factors is left. So that means the given number is a perfect cube. Now to find the number whose cube is the given number, we take one factor from each triples and then multiply them. So here 2 triples are there. So from first triple we write 2 and from the second triple we write 3. After multiplying we get 6. So cube of 6 is the required given number. That means 216 is equals to 6 cube, and which is a perfect cube. Let's see another example. Is 128 a perfect cube? Here the given number is 128. Now expressing 128 as a product of prime factors, we get here already all possible prime factors is shown. So there are total 1, 2, 3, 4, 5, 6, 7. 7 2s are there. So expressing 128 as the product of 7 2s, here it is already shown. Now after that we make a groups of the equal prime factors in triples. So there are how many groups we are getting? Here in the first group 3 2s are there. In the second group 3 2s are there. And at last 1 2 is left, which is not in the group. So which can also be written as 2 cube multiplied by 2 cube multiplied by 2 cube. Multiplied by 2. So after grouping the equal prime factors in triples, we see that one prime factor 2 is left ungrouped. So we can say that 128 is not a perfect cube. It's not a perfect cube. So in this way, we can check any given natural number whether it is a perfect cube or not by using prime factorization method. So I hope all of you understood this method. So you will try the questions which is given in your book. Thank you and have a nice day.